need to freeze. So for this, how many grams of oxygen are in 1 mole of oxygen gas? Let me ask you a different question. What is the formula for oxygen gas? It is O2. This was a 2-part question. So first you need to realize oxygen gas is not just a single oxygen. Oxygen is one of your diatomics. It is O2. On your desk, that mass that is there for oxygen is the mass of 1 oxygen, not 2 oxygens. And some of you are like, but oxygen's always paired with something else. If it's by itself, it's paired with another oxygen. You can have an oxygen by itself. You can have, say, if we look at one we've already done, and let's not go with that one. Let's go with H2O. Right, in H2O, there's only 1 oxygen. This is an O2. So that mass that is on your desk is the mass of a single oxygen. And you look at your desk and you're like, oh, well, that single oxygen has a mass of 16 grams. So if you have O2, well, how many oxygens do you have? You have 2 of them. So you need to double that mass, and you should get an answer of C, 32 grams. And then question number 2, how many moles of lithium are in 13.88 grams of lithium? So you need to convert from grams to moles. You start with what's provided to you, which is 13.88 grams of lithium. And then if you have grams of lithium on top, what do you need on bottom? Grams of lithium. And where do you get that information? You look at your desk or you look at your green sheet and you see lithium has a mass of 3.84, what is it? 6.94? 6.94 grams. And that is per 1 mole of lithium. Okay, your grams of lithium cancel out, grams of lithium cancel out, and you are left with moles of lithium, and you should get an answer equal to 0.5 moles. So, 2 moles, sorry. 2 moles. 2 moles is your answer for that one. All right. Stoichiometry. Everybody's favorite chemistry word. Stoichiometry is a branch of chemistry that deals with quantities of product and reactant. So now we are talking about the number, quantity, the amount of each. Many things that we do or interact with have been produced with this in mind. When you're baking, you need to know your ratio of flour to sugar to eggs to whatever. You need to know all of those ratios. You don't just take random amounts and throw them all together. Or sometimes you're going through and you're baking cookies, you're like, shoot, I only have 2 cups of flour. Well, and then you have, say, unlimited brown sugar and unlimited regular sugar and whatever else. Well, that little bit of flour, those 2 cups of flour, you're like, well, shoot, how many cookies can I bake now? You need to have a proper ratio of all of your products. So that is really what stoichiometry is making sure that you have enough of everything, or that you are mixing proper ratios of everything. So when you go through and do this, you use what we call the mole-to-mole ratio to convert from one substance to another. That is, they are the coefficients. The mole-to-mole ratio are your coefficients. From the balanced chemical equation, you still need to balance your chemical equations. That doesn't just disappear, that doesn't go away. You need to know, well, how many of this do I need to produce this, or how many of this and this have to go together to react. Just like when, again, you bake cookies, if you need 3 cups of flour, 2 cups of sugar, and a cup of brown sugar, that's your ratio. It is a 3 to 2 to 1 ratio. And that's what we're talking about today. Let's play another game. If I have a mole of Lego Elvis bodies, and then I have a mole of Lego Elvis legs, how many total moles of Lego Elvises did I make? 1. I still only have 1 mole of Lego Elvis. I just took 2 things and combined them together. So you still only have 1 mole of Lego Elvis. Think about it. Here you could have 12 legs, or 12 heads, and 12 legs. And if you smash all them together, you're only going to end up with a total of 12 LIGO Elvises. Hoping that can kind of be a just kind of starting point. Or let's think of it this way. If I have magnesium, and I'm just going to extend this page a little bit. And the reason I tell you this is, let's say I have one magnesium atom, and I have one sulfur atom. And then my magnesium has a charge of +2, my sulfur has a charge of -2. And they join together. I do a reaction of magnesium plus sulfur, and they join together. And they produce magnesium sulfide. So now I have magnesium and sulfide, or magnesium sulfide bonded together. Well, I had one magnesium, I had one sulfur. So how many magnesium sulfides do I have? 1. So 1 plus 1 does not always equal 2 in this class. Another simple thing, because students never forget how to ride a bike, is let's do this another way. If I want to produce a bicycle, and we have one frame, how many tires do I need to make a bike? This is another example of a mole-to-mole ratio. Well, if I have one frame, I want to make a bike, how many tires do I need? We would need 2 tires. So if we work our way down in chemistry form, it is going to be one frame plus 2 tires is going to give me how many bikes? 1. That's what we're doing with atoms when we combine everything together. So here, if I have 12 tires and unlimited or excess frames, so I have unlimited frames, I have an entire factory full of these bike frames, but I only have 12 tires. How many bikes can I make? 6. Seems pretty easy, right? A lot of you can do that in your head. When we get to chemistry terms, students start to struggle a little bit more. But we can still solve this using stoichiometry. So here we scroll down. I have 12 tires. The ratio, if you will, the mole-to-mole ratio of your tires to your bike, so we're going from, I have 2 tires for every 1 bike. Well, that's my ratio. That's my conversion factor. Is I have 12 tires, 5 tires on top. What do I need on bottom? I need tires. So my tire units cancel out, and I have 2 tires for every 1 bike. Hey, look at that. I can produce 6 bikes. Seems easy, I know, and you're like, oh, why is he saying this is one of the hardest units? I'm making this as simple as I possibly can right now. So here's another example of a mole-to-mole ratio. You can produce water if you mix hydrogen gas and oxygen gas. This is another example of a ratio. You have 2 moles of hydrogen. So these 2 moles of hydrogen are equal to 2 moles of water. For every 2 moles of hydrogen you use, you can produce 2 moles of water. For every 1 mole, this is a 1 right here. For every 1 mole of oxygen, you can produce 2 waters. And for every 2 moles of hydrogen, you need 1 mole of oxygen. This is more of just a chemistry example. So for every 2 molecules of H2O that are used, 1 molecule of O2 is used. These are conversions, just like everything else we've done. So we can use them in calculations just like we would say there are 60 minutes in an hour or 1 kilometer in 1,000 meters. I can say that I need 2 moles of hydrogen to produce 2 moles of water. Or I need 1 mole of oxygen to produce 2 moles of water. Or I need 2 moles of H2 to react with 1 mole of oxygen. So basically what we're doing when we say our mole-to-mole ratio is we're looking at our coefficients. All right, let's do this last example and then we will take a brain break. So first, we need to balance. Balancing does not go away. Okay, look at that. I even gave you the same problem that we had last time. If we were to balance this one, you go through and you're looking, all right, I have hydrogen gas, oxygen gas, which is O2, and water. When we balance, we're like, oh, shoot, I only have 1 oxygen on the right side. How do I get more oxygens? Oh, we're just going to put 2 there. All right, now I have 2 oxygens on the right, 2 on the left. Those are good. But now my hydrogens aren't balanced. I have 4 total hydrogens. Okay, now I have four total hydrogens. So how many moles of oxygen are required to react completely with 6 moles of oxygen? Let's look for our keywords. How many moles of oxygen are required to react completely with 6 moles of hydrogen? And I'm going to give you guys a minute to work on this one. Hopefully some of you are done, but I want to walk around and see if this is making any sense. All right, so looking at this, I think I saw about 1 person with the correct answer. So the bike example made perfect sense to you guys, which is just fascinating me. You guys gave me an answer, and as soon as I switch into chemistry things, it suddenly becomes a lot more confusing. So let's jump back and look at this one. In my bike example, we had 1 frame plus 2 tires creates 1 bike. And you're all like, well, duh. That's gonna, if I start with 12 tires, I'm gonna be able to produce 6 bikes. Well, let's just turn this into a similar example. Here, let's pretend that this is now my tires. This is now my bike, or my frame, sorry. And this is now my bikes. And we're like, all right, well, this time I'm starting with 6, and hydrogen is now my tires, so I'm going to start with 6 tires. And what am I going to? I'm going to my frames. So if I start with 6 tires, how many frames do I need? Well, most of you would be like, well, 3. Oh. Well, if I have tires on top and any on bottom, hey, I need tires. So I'm going to write my tires then. How many tires do I have to each frame? I have 2 tires to each frame that I use. And hey, look at that. I would need 3 frames. So now I'm going to take this, and I'm just going to rewrite this in chemistry form. And we're like, all right, so now in chemistry form, how many hydrogens am I starting with? Well, we're starting with 6 hydrogens. So we're starting with 6 moles of H2. For every 2 moles of hydrogen gas, for every 2 moles of H2 that are used, I only need 1 mole of oxygen. If I have moles of H2 on top, what do I need on bottom? Moles of H2. How many? Hey, look at that. There are 2 moles of H2 per 1 mole of O2. Then we go through and get an answer, and here, look at that. We end up with 3 moles of O2 would be required. Does that bike analogy help? I mean, does that help and make sense? Yeah. Kinda, sorta, I don't know. I felt like I would try it out. But it's really the same thing. You're doing a 2-to-1 ratio. We'll take brain break. Stretch, that's been a lot for today. All right, let's do another example. So if we have aluminum chloride plus lithium, producing lithium chloride plus aluminum, what's the first thing we should always do, Miss Avery? Before we even start the rest of the problem, what do we need to do first? Yes, Mr. Zimmer. We do need to balance, Mr. Zimmer. Excellent. Yes, let's go through and balance this one. On the left, we have 1 aluminum. Hey, we have 1 aluminum. We have 3 chlorines on the left. Oh, we only have 1 on the right. So first thing I'm going to start off by doing, I'm going to add a 3 there. And then you're like, all right, now my chlorines are balanced. Oh, I changed my number of lithium. Well, look at that, we're all good. We have 1 aluminum, 3 lithium, 3 lithium, 3 chlorine, 3 chlorine. Life is good. Now we can actually start looking at the problem. How many moles of aluminum are produced when 0.750 moles of lithium react with excess aluminum chloride? Realistically, in these problems, this is kind of extra information. All this is saying, when we say react with excess aluminum chloride, it just means that my cupboard is full of it. I have unlimited aluminum chloride. It doesn't even matter. But I only have 0.750 moles of lithium. So that's what's going to limit how much aluminum can be produced. So we're going to start this one off, and we're like, all right, my given information, I have 0.750 moles of lithium. Perfect. Well, then I just need to simply look. Oh, actually, first we'll just think to ourselves, 5 moles of lithium on top. What do I need on bottom? Mr. Calvin, move back to your desk. 5 moles of lithium on top. What do I need on bottom? Yeah, we need moles of lithium. So we can write that in. Well, what is my ratio? I want to go from lithium to aluminum. Well, what's my ratio of lithium to aluminum? Here, look at that. I have a 3-to-1 ratio. Realistically, again, this means that there's a 1 here. So I have a 3-to-1 ratio. So we're just going to write that in. We have 3 moles. For every 3 moles of lithium that I have, I'm going to produce 1 mole of aluminum. And with that, we will get an answer equal to 0.250, sorry, I ran out of room, moles of aluminum. And the reason for that, the reason that we end up with less aluminum is because for every 1 aluminum I want to produce, I'm required to use 3 lithiums. Just like in your bike example, or say we're building a tricycle. For every 3 lithiums I have, I'm only producing 1 tricycle. So for every 3 tires I have, I produce 1 tricycle. It's kind of the same idea. Never heard that. That's good. All right. When we need to find the quantities of reactants to use or amount of product produced, we use this method. If I were a young high school chemistry student, I would add some big old stars to this page. Probably the biggest stars you have ever added in your entire life. Because this is by far the most important page that you will ever use for this unit. When we need to find the quantities of reactant, we use this method. What this is telling you is if you want to go from grams of some sort of substance A to moles of substance A, here's what you use. Please look at these in-between steps. You use your molar mass, which is found on the periodic table, will always be some sort of grams per some moles. So if you want to convert from grams to moles, hey, look at that. You look at your periodic table. So if you want to go from grams of A is just any general reaction, chemical, compound, whatever, to moles of that same thing, you look at the periodic table. If you want to go from grams of some sort of compound A to moles of a different product, you are going to first go from grams of A to moles of A, and then you go from moles of A to moles of B. Well, how do you convert from moles of A to moles of B? You use your mole to mole ratio. You use your coefficient A to coefficient B. So again, coefficients are your numbers up here. So your mole to mole ratio of lithium to aluminum is a 3-to-1. It's like the whole bicycle thing. And then if you want to go from grams of substance A and you wonder, well, how much of substance B would I need? You have to do all of these steps in between. Again, when you get this down, it becomes like a minute process. It really becomes quick. But the first few times you do this, it's going to be the most chemistry fun you've ever had in your entire life. And when you go from moles of B to moles, or grams of B, guess what? You do the same thing. You look at your periodic table. I can't tell you to star this page enough. This is going to be your new lifeline, is following this, and you'll get it down where it becomes very simple. So let's practice. How many grams of aluminum are produced when 3.50 grams of lithium react with excess aluminum chloride? Hey, look at that. It's basically the same problem, except for now, instead of going from moles of lithium to moles of aluminum, we are now going from grams of lithium to grams of aluminum. So how are we going to do this? If we have 3.50 grams of lithium, that's what we're starting with. We have 3.50 grams of lithium. Let's switch back. Let's look. What is our next step? So we are going from grams of substance A. Are we converting to a different substance? Yeah. We are. We're going from lithium to aluminum. So we're going from a substance A to a substance B. So what steps are we going to follow on the previous page? We're going to go from grams of substance A to grams of substance B. So we're going to have to do 1, 2, 3 different steps. So when we go through and do these steps, the first thing that it tells us to do, if we want to go from grams of A to moles of A, what do we have to do? We have to use the molar mass found on our periodic table. Well, what's our molar mass found on the periodic table? 5 grams of lithium on top. Guess what? We need grams of lithium on bottom. How about our 5 grams of lithium? We look at the periodic table, and the periodic table tells us that the molar mass of lithium is 6.94 grams. And what is that number equal to? What do we put on top? 1 mole. Because again, if we go back and look, it says on here, will always be some sort of grams per 1 mole. That is our conversion. So that means that is per 1 mole of lithium. And again, that is telling me 1 mole is equal to 6.02 times 10 to the 23rd atoms. So if I have 6.02 times 10 to the 23rd atoms of lithium, they are going to weigh 6.94 grams. Hey, look at that. Step 1 is done. So if you like to, guess what? You can go through, cross out. We're done with that step. And now we are at the step where we have to go from moles of A to moles of B. This is our mole to mole ratio. This is our coefficient of A to our coefficient of B. So we're going to go through and do that now. 5 moles of lithium on top, what on the bottom? Moles of lithium. Perfect. Well, the previous step is telling us we need to go from coefficient A to coefficient B. My coefficient of lithium is 3. My coefficient of aluminum, which is my B, what I'm converting to, is 1. So we are converting to moles of aluminum. That is telling me that I need 3 moles of aluminum for every 1 mole, 3 moles of lithium for every 1 mole of aluminum. And we jump back a page. We're like, all right, step number 2 is done. And now we just need to do our final step. We need to go from moles of B to grams of B. So how are we going to do that? Well, if I have moles of A on top, what do I need on bottom? Moles of Al. And that will always be 1 mole there. And again, this page is telling us use molar mass found on the periodic table will always be some sort of grams per 1 mole. Well, what's our molar mass of aluminum found on the periodic table? 26.98 grams. And then we go through and we plug this into our calculator. We're done. 3.5 times 26.98 divided by 6.94 times 3. And you get an answer equal to 6.22 grams of aluminum. That means if you did this reaction, and you start with 3.5 grams of lithium, and you went through and did this process, in a perfect world, you would end with 6.22 grams of aluminum. Here's another example. If we have 17.5 grams of copper 2 chloride, and they're reacting with excess aluminum, so again, we just have unlimited rolls of aluminum foil, how many grams of AlCl3 would be produced? So we are now going from a grams of A to a grams of B. I want you guys to try this one out. First thing you need to do is let's go through and actually balance this one together. Let's see, 2 chlorine and 3 chlorine, so we need our lowest common denominator of 6, so we're going to add a 2 here, 3 here. We now have 3 coppers on the left, 2 chlorines. All right, we're balanced. Okay, go through, try this one on your own. I will walk around and attempt to help you individually. Please keep jumping back 2 slides. Utilize that last page to walk you through the steps. It is meant to be challenging for now. But if you use that slide, I hope that it will get you through it. All right. I would like to go through and work on this one. Then I think I'm just going to consider us probably done for the day. I know there's some more stuff on the back. I might just not worry about that. So anyway, if 17.5 grams of copper 2 chloride looks like one of the most common mistakes was just recognizing. Well, what is copper 2 chloride? We have to remember our names. Since you all told me Roman numerals indicate charge, if we go through and look at copper 2 chloride, that is saying that I have a copper with a +2 charge paired with chlorine, which has a -1 charge. So to get my overall charge of 0, how many chlorines do I need? 2. So that means we need 2 chlorines, which gives us a formula of CuCl2, which honestly is actually written up there. So when we go through and do this one, first thing we should do is be like, all right, well, we need copper 2 chloride. We need to find the molar mass of that. So we are going to take, and we're going to add the mass of 1 copper and 2 chlorines. And we see that 1 copper is equal to 63.45, 46, something like that. What is it? Oh, 63.54. Thank you. So mass of 1 copper, 63.54 grams. And then we have 2 chlorines. And those each have a mass of 35.45 grams. Then we're going to add these together, and we are going to get a total of, was it 134.45 grams. And that is per 1 mole. And that is our molar mass of CuCl2. And then we also know we may as well just figure this out right away. We also need our molar mass of aluminum chloride. So let's just go through and get that right away. Now we have 1 aluminum, which has a mass of 26.98 grams per mole. And we have 3 chlorines in this case, which have a mass of 35.45 grams per mole. And so when we go through and we add all of that together, we get a mass of, can somebody tell me? I don't remember. 133.34 grams per mole. And that is equal to our AlCl3. All right, we laid some of the groundwork. And now we come back up and let's actually start the problem. So we are going from our grams of A. We are going from 17.5 grams, and keep in mind this is CuCl2. And if I have grams of CuCl2 on top, what do I need on bottom? Grams of CuCl2. I know that's all of your least favorite question, but the reason I do it is because I will still, and I guarantee probably 25% of you are going to try going against that rule, and you will unfortunately be wrong. Follow that rule. It gets you pretty much everywhere. 5 grams of CuCl2 on top. Before we even write numbers, let's just write grams of CuCl2. And how many grams of CuCl2 do we have? 134.45. And that is per 1 mole. And now if we jump back 2 slides and look at this, I should have done this right away. If we jump back 2 slides and look at this, hey, we're done with going from grams of A to moles of A. Now we need to go from moles of A to moles of B. So we are going to use our coefficient of A to our coefficient of B. Well, our coefficient of A, copper 2 chloride, is 3. Our coefficient of B, aluminum chloride, is 2. So when we write this in, we now have, and if I have moles of CuCl2 on top, I need moles of CuCl2 on bottom. And that is going to be a 3 to 2 ratio. And that is now 2 moles of AlCl3. And look at that, we're done with our second step. Last thing we need to do goes from moles of B to grams of B. And again, we use our periodic table. We already went through and solved for that. If I have moles of AlCl3 on top, I need moles of AlCl3 on bottom. That is 1 mole. And my mass for that is 133.34. And what was that answer? 14 something? 11.5. Okay. Thank you. And that is 11.5 grams of AlCl3. And again, make sure you always cross out your units. We had grams CuCl2, grams CuCl2, mole CuCl2, mole CuCl2, moles of AlCl3, moles of AlCl3. And look at that, we are left with grams of AlCl3. That is some chemistry fun for the day. Again, when you get this down perfectly, you can usually get these done in about 2 to 3 minutes. Sometimes they take longer. This, honestly, this is probably the most challenging part of the entire unit. Tomorrow we get into more conceptual stuff, but as far as the math portion goes, this is it. This is all of it. Tomorrow becomes more conceptual when we talk about, well, what is limiting, what is excess. We do have this, and then I have one last thing to show you. Sorry we didn't end up with as much work time as I would have liked. But let's do these. I love these. These are my favorite. Oh yeah, they're jokes.